That's how the IV estimator looks like, right? The beta hat IV. So you remember, OLS means beta 1 hat. Beta 1 hat is covariance xy over variance x. Okay? That's the OLS estimator. Now let's have a look here. What is different? Well, in the numerator you have covariance set y, and in the denominator you have the covariance set x. Set x. So this seems to be a little bit different, right? And so you have two covariances, and therefore the metrics cancel out, right? So assume now the covariance set y is measured in, let's say, meters, and the covariance in the denominator is also measured in meters. So this cancels out, the matrix cancels out, and at the end of the day you have a number, let's say 0.11. That's the first thing we can observe here. And the second thing is, if set, the instrument, is identical with x, so that we do not have a heterogeneity problem, right? So if we have heterogeneity and we do not need an instrument, if this is the case, then you see that the IV estimator is then identical to the OLS estimator, because if you insert here x, right, and here also x, then this turns out to be covariance xy. That's what we already see here in the numerator, and divided by covariance xx, and we know from our covariance variance rules that covariance xx is variance x, and then it turns out that this is once again the beta 1 or the beta OLS hat. And so this is important to see that the OLS estimator and the IV estimator coincide in case x is exogenous. Now let's continue work with the Mince equation. I already started with that. Take the standard way to phrase that with log wage on the left hand side and education on the right hand side, and assume now in the first step that this is your original simple regression. If this is your simple regression, you have only one explanatory variable on the right hand side, so the x here is education and the rest is hidden. The error term, in this case the error term is u, could also write epsilon. So education is obviously endogenous because something is hidden in the error term, and let's say it's ability that is hidden in the error term, right? And if you take, because you have the data, ability out of the error term, right, and also regress on ability, then your result is closer to reality, okay? And so if you just do the simple regression, OLS would be biased and inconsistent because the omitted variable bias here, the covariance xu is not 0. And then you have an heterogeneity problem, so that an outcome, let's say that would be then 11% is either over or underestimated due to the omitted variable bias. Now let's make it concrete once again with college proximity as a potential instrument set for the endogenous variable x, which is education in case of a Mince equation. So if you take set as a binary variable, so set equals 1 if you're living near the college, and set equals 0 if you live far from college, and it has of course to be made clear what is near and what is far, then you could check the relationship between the instrument and education. So first, you have to argue that there is no correlation with the error term. So that would be the exogeneity condition. You can only argue, you cannot check that empirically, and you just can come up with arguments, right? And the second is that and that's what you can check, is the relevance condition. And the relevance condition is that there is a relationship between the endogenous X and your proximity to college dummy variable. And that's what you could do via a regression, and that's what we typically call the first stage. If you then estimate the IV, it turns out that the IV effect is 13.2%, which is much larger than the original OLS effect, and that has to do with the negative correlation between the instrument and the endogenous correlation, so that OLS underestimates the true value. So in reality, the value is much higher because something that pushed down the OLS result is hidden in the error term, that's proximity to college. Another famous paper using an innovative instrument is from Enquist, 1990, American Economic Review. So he checked the earnings of veterans, and obviously veteran status is not exogenous, and then he searched for an instrument, and he found an instrument, a binary instrument, going back to random assignment. So if you go back to the Vietnam draft lottery 1970, you could see there was a randomized procedure. Either you are drafted or you're not drafted, just depends on lottery numbers. So at least in theory, and probably mostly in practice, this was random, whether you were drafted or not drafted. And because this is random, there is a correlation between the status of being a veteran and here that random assignment, because low numbers in the draft lottery meant that you had to come up, had to show up in Vietnam. So this is random. There is a correlation, but it's random, right? And due to that randomness, you could argue that here the instrument is uncorrelated with the error term. The result, if you believe that identifying assumptions, then the result is that veterans earn less 10 years later, and theoretically that's the penalty for lack of labor market experience, so those veterans are hit twice. Now let me mention here heterogeneity. So far we have argued with binary instruments, so 0-1 instruments. And if you go through that here, we have several subgroups. We have so-called never takers, independent of being assigned to the treatment or not treatment group. They never take the treatment. Or the always takers, independent of being assigned to the treatment or to the control group. You are, in any case, you get the treatment. Then the compliers, that's the group that is especially important later on if you talk about the local average treatment effect. The compliers are those who change their behavior in line with the instrument. So if the instrument changes from set 0 to set 1, so then you also behave in line with the instrument. That's the idea. To make that once again clearer, just using an example, then it's getting better. So if your instrument is that you live near college, right? And this is a binary instrument. You live near college, then it's 1. The dummy variable set is 1. Or you live far from college, then your binary dummy variable is here 0. Okay. And now if the instrument switches from 0 to 1, so if you take a closer look to people living near the college, then a compiler behaves in line with the instrument, and this would then say that a compiler has more years of education, because the compiler is then getting more years of education due to that closer proximity to college. The defier, on the other hand, is then somebody who reacts in a perverse way, just doing the opposite than the compiler.